Hi everybody, so I'm going to quickly go through the answers, solutions to the quiz, try to give you an idea of how many points there were for each problem and then why you might have lost a half point or up to 3 points. The first one, no one really had any issues with. The answer is C. They're equally spaced at the beginning, so that's constant speed, and then they get further and further and further apart, going faster. All right, a lot of you missed a half point in this because you didn't. I want measures of motion that are scalar. So distance, half a point, each one's a half point, speed, and time. Some of you said mass, volume, stuff like that. Those are scalars, but they're not measures of motion, so that's why I might have lost a half point. Velocity and acceleration are vectors, so they don't count. All right, I run 2 times around a track. I want to know what the average speed is. Average speed at this point, you should have been using total, how far we went divided by time. Actually, it's just total distance, not a sigma. So in other words, 2 times around a track for a total of 8. So it's 800 divided by the time. Okay, so it was 30 seconds and then 150 seconds. So 30 plus 150 is 180, and that's meters, that's seconds. That gives you 4.4 meters per second. You can't take the average speed for each segment and then take the average of that. We talked about that, how that doesn't work. So this is what's 2 points for that. Next problem, Mr. G trying to catch Mr. S. Mr. G is definitely going faster, so if you put that, you got automatically 1 point. The second point is your explanation. A lot of you had the wrong explanation. Many of you said Mr. G is going faster at the end because he's going faster at the end, which is circular reasoning. You had to basically explain how him catching up, or not caught up, but catching up, is indicating that he's going faster. So that's the key thing there. You can't get closer to somebody if you're not going faster than them. So even though he crossed the finish line later, which means he had a lower average speed, the fact that he was catching up at the end is important. Doesn't matter whether I was slowing down or not. If you said he's going faster because then maybe because he started sprinting, just because he's sprinting doesn't make him going faster than me. He could have been going very slow, sprinted to a faster speed that was still slower. So the catching up is the key. Okay, in this problem, this was 3 points. And a lot of you got the right answer, which is Kendall. So if you just said Kendall and you had the wrong reasoning, you got at least 1 point out of 3. But what I was looking for, so 1 point is saying Kendall. You can figure out acceleration from this graph. You just have to do it in steps. So the second point, if you wanted to get the full credit, is you want to indicate that the slope is changing, therefore we're accelerating. Okay, so slope, you can't just say we're accelerating, you have to say how do you know we're accelerating. Slope is changing, therefore accelerating. I'm not going to write that all out. Something to that effect. And then the third point is how does she know it was a negative or an acceleration backward? So you had to put 2 pieces of information together. The fact is we're speeding up. In other words, the slope is getting greater. And we have a negative velocity because the slope is negative the whole time. So if you have a negative velocity and you're speeding up, then the rule is the direction of acceleration must be in the same direction as the velocity. In other words, a negative acceleration. So when I ask you to explain things, it's important that you be as thorough as possible. You don't have to write lots and lots and lots and lots of words. I'm doing it in bullet points and I can keep it succinct, but I'm very complete in what I'm saying. So again, how you tell acceleration, the direction of acceleration, is by looking at the direction of velocity and then saying, are you going faster or slower? If you're going faster, they're in the same direction. If you're going slower, they're in opposite directions. Moving on. So I was very surprised how many of us could not come up with 2 legitimate descriptions of motion. You get 1 point if you got one of them, and then it was a half point for the other. And many of you lost the other half point. So there's 3 things you could have said that is the same about their motion. First, they're moving in the same direction. Okay, they're moving forward. They're going from a negative to a positive. In other words, their position is increasing the whole time. It's not good enough to say that they started at the same time or started negative, or they're moving for a time. We know they're moving, but that's not a description of their motion to say that they're moving. The other thing you could have said is they have the same displacement or distance on either one. Okay, in other words, they started at different spots, but right, if we follow Ariel, she started further away, but she ended up in other words, a change, how can I put this? They both went 6 units of distance. And since they went 6 units of distance in the same time, you could have made the third statement and said they have the same average speed. Those are descriptions of motion. Okay? Notice I'm not saying rate of this or that. Okay? That's too vague. This one is changing. This one is constant. So that's definitely not the same. So this goes, that what I just talked about goes towards letter B. Letter B had to be more specific, and it was 2 points. Basically what I was looking for is Byron, or actually Ariel, is constant speed. You got to use the word that's speed. Okay, so 1 point for saying he's moving at a constant speed. It's not good enough to say at a constant rate. Rate can be acceleration. Rate can be speed. Be more specific. If you said constant rate of position, then that's speed. I could accept that. For Byron, you had to be specific. It's not good enough to say he's changing his speed. If you said that, I gave you half a point. He is changing his speed. But you can be more specific than that, saying that he is speeding up or gaining speed. Okay, the slope is getting steeper, which means speeding up. So you have to say speeding up. That's what specific means. Changing speed is correct, but it's not specific enough. And then the last one, C, is where a lot of us struggled with this. That was worth 3 points. 1 point for getting the right answer, which is yes, they are moving. There is a time when they are moving at the same speed. And then the other 2 points is based on your explanation. So I don't know why I'm doing that. So your next point was to say something about slope is how we look at speed. Okay? And then the third point is when are their slopes the same? In other words, what specific point are they the same? Well, the slope of Ariel is constant, right? It's shaped like this. So we want to know at what point is Byron's speed have the same slope, and it's right around here. In other words, if I draw the tangent there, I see it's parallel. So at time 6, we're going the same speed. So that was the third point. For those of you who said that the speeds are the same here and here, the average speeds are the same there and there. And that wasn't looking for average speed. Okay, so you got the right answer, but for the wrong reason, because you were talking about average speed. Same speed implies an instantaneous. So you got to be careful of details on some of these, which some of you are overlooking. Okay, now looking at the velocity time graph. At which time is the motion forward? For a velocity time graph, forward means a positive velocity. So that's A through E. They're always positive. Even E is positive. I have a positive 40 here and moving down to 0. So at no point is that speed ever negative. Okay, so that was worth 1 point, I believe, for that whole thing. If you missed, maybe it was 1.5. I don't remember. All right, where is the speed increasing? Okay, so when it's going from a lower value to a higher value, clearly A, clearly C, but also F. F, we're going from a speed of 0 to a speed of 20. The negative just means direction. So that was worth 1 total point. If you missed any one of those, you lost a half a point. At what time is the speed 0? When it crosses the x-axis here, and at time 0. So 0 and around 9 point something. Okay, now I ask you from 2 to 4 to find the acceleration, average velocity, and then calculate the displacement. Okay, so let's block off that 2 to 4. So 2 to 4 is from here to here. Okay, acceleration most of you were fine with. It's just the slope of that. So you're going to say 40 minus 10 divided by 4 minus 2 or something like that. That's 30 divided by 2, 15 meters per second squared. Average velocity, you're not going to use displacement divided by time because you don't have the displacement. So what you should use is initial plus final divided by 2. And there shouldn't have been no guesswork on that. I saw somebody do subtracting that. So 40 plus 10 divided by 2 gives us 25 meters per second. Displacement was the most difficult, and that was worth 3 points. So displacement is the area under the graph. So look what I did to find the area. So the easiest way to do that area is to simply break that parallelogram into a triangle and a rectangle. So there's 2 parts to this. So if I do this part, that's going to be a base of 2, right? 4 minus 2 multiplied by a height of 10. So that's 2 times 10 for that rectangle plus what I have for here. For here, my base, again, is another 2. So it's 1/2, because it's a triangle, times 2. And then my height goes from 10 to 40. So that's a change of 30. So this term is 20 plus 30 times is 60. 60 times 1/2 is 30. Add them together, we've gone 50 meters. And that was worth 3 points. 3 points, 2 points, 2 points. All right, which segment or segments is the acceleration opposite direction of the velocity? Okay, so the answer is E and only E. Maybe we'll quickly go through this. This has a positive velocity and a positive acceleration. The slope is the acceleration, and velocity is simply above the x-axis. Positive velocity, positive acceleration. Here we have a negative acceleration because the slope is negative, but a positive velocity. Here we have a negative acceleration again, but a negative velocity because we're below the x-axis. So that's why that's the only one. I could have asked you, what does that mean? It means it's slowing down. All right, now make a graph of A and B in position time. So I'm going to draw A and B. That's what it looked like from a velocity time graph. So we're gaining speed. So gaining speed looks like that. And then here we're going constant speed. So we got to make clear we're straightening out from there. Some of you it wasn't clear. I might have taken off a 1/2 point. For E and F, I wanted you to sketch what the acceleration time graph is for that. Here's E, here's F. Acceleration is a slope. The slope is negative and constant, negative and constant. They're staying the same. So it should be simply like that. Okay, this is worth 2 points. This is worth 2 points. 1 point for this part, 1 point for this part. This part I broke down is if you had flat, that was 1 point. If you had it negative, a 1/2 point. And if you had a consistent value, you didn't shift it, then that was the other 1/2 point. Okay, so if you still have any questions and you're going to take the retake, please ask me. I'm going to guess many of you made mistakes because of details, little things. There's a lot of information you need to bring to this, and that's what we're trying to test you at this very high level.